So hi guys, my name is Arpit and this is the part number 6 of this project playlist, and it's been quite late after putting the part number 5. So I've just changed my IDE because previously I was having Spider IDE that comes from Anaconda, and now I'm having IDE of PyCharm. So it doesn't affect our code, and so let's start it. So like in the previous video, we have seen that all the things like face data collection, video camera on, like how to do that, face recognition, okay, all of that. And now like we have to do like the last practical part of it, like we have to recognize our face after loading the data of the faces, right? Like I will open my webcam and I will upload my data. Like I will start the webcam and my camera feed will constantly and consecutively load my data, okay? And after that, like my facial data will be stored in a numpy array, and in prediction I will use that numpy array for in my KNN algorithm to predict my new face, okay? Okay, so basic overview that like in your family just record the faces of 4 or 5 people, and after that in the data collection record that, and while the data recognition just one person come in the camera or multiple persons, and a label will be come and around your face and a box will come. I will show you that later, okay? So till then, just see here. So this is our face recognition code, okay? So like we have done this base data collection, and like everything we have done till in the earlier classes. And this is a Haar Cascade classifier which we have used for detecting the facial components. And now like let us see our face recognition file. So basically like we have now like we have discussed KNN algorithm in the earlier class, like how our face is detected in the bunch of many faces, okay? So like this is my KNN algorithm. I have not used the library function, rather than I have coded it from scratch, okay? Like I will show you later. Like I have also told you to study this KNN code by yourself. So basically it is nothing, just calculating the Euclidean distance and just calculating that which face is the nearest face to the point of convergence, like to our new face, how many previous faces are near to us, okay? So like like that thing is done here. Like I have also given comments and just you can read that, okay? And like I will share this code, I will share the GitHub repository so that you can read the code and understand it and run it in your computer, okay? And as of now, let me just unhide the scale code. Okay, so now let me just unhide it. Okay, so I have just minimized my KNN code. So let us see now like what further things I've done in this part. So like initially, like while I have to recognize my face, so before that like basic steps has to be done as we have done in previous classes. Like okay, so like we have to first open the camera. Like when we open the camera, then only we can like put our face in front of it, right? So first we open our camera by cv2 dot video capture 0. By this we are opening our webcam, like there is an OpenCV function video capture, and by this we open our webcam, and like with C, and I have stored my webcam in this cap variable. So cap will contain my webcam, okay, my video feed basically. And after that like I have called my classifier, that is Haar Cascade classifier, and the function to call our classifier is Cascade classifier, okay? And there are multiple classifier, like Haar Cascade frontal face classifier is only used for like detecting your faces, and there are multiple classifiers like which are used for detection the number plate of the car, or a person is the gender of a person, or many things. So there are like a lot of classifiers which have already been made. So we have used Haar Cascade classifier to classify a particular part of the faces, okay? And after that just see this data set path. So like in previous video we have seen that whenever we are capturing our face, then we are storing that face in a particular data file, okay? So just see here, face data collection. Here we have stored our face. I think here, just see here, like we have stored our face in this dataset path, okay? And this dataset path is basically this folder, Now, like when I show you this folder, so just see here. I think this is a folder. Okay, just see this. Okay, so this is a folder that is like my this is my folder basically, which contains my all the files, Python files, and this is my face dataset folder, in which all the faces, like whatever the name I've given in the data collection, is being written here in the .npy format. So if I open this like face data, then you can see that when I was printing it, then I was printing in such a way like dot format dataset path plus file name plus .npy. Okay, so you can see that like it is my dataset path is face data, and dataset name and file name is this, like uh, this is my name, and this Arpit the media is the file name, and .npy is the extension. Okay, so like this is my stored data, and now I have to use this data. So like in face recognition, uh, I will be using my this facial data for the recognition part. Okay, and this is our normal arrays by which we are just calculating our facial data, like where we are storing our data, and label are the name of the data, like what is the label like currently, and class ID, like I have made two new variables here, class ID and names. So class ID will be basically labels for every given file. Okay, and names are like we are mapping a particular name with a particular data file. Okay, and now let us see like how to do data preparation. Okay, so like just see this line, just see this loop for fx in os.list directory dataset path. So basically os is a another library in Python which is used to for interaction with our operating system. OS basically means operating system. Okay, so here you can see that like I have also imported this OS file, OS library basically, and now I'm using that. So by this os.list dir, it means list directory and dataset path. So this line is basically looping in my this folder. Okay, this is my folder face dataset, and here my like this loop is like this line is iterating over this folder. Okay, so every file, like every file which is present here will be in the fx, like we will be iterating over every file, and like in this line fx dot with end with, it is just finding that which file ends with this extension .npy. So basically if I made some new file here, like if I made a new folder here, suppose new folder, and suppose I make a Word doc here. Okay, so like I made a new folder and a Word doc. So basically if these folders are present in my file, so I have to just find the .npy files. Okay, so with if fx dot ends with .npy, I am finding just only .npy files where my data are stored. Okay, where the different faces data are stored, I'm just finding those files. Okay, and like just see names names bracket class id is equal to fx colon -4. So I hope that you remember the slicing operator we have discussed in previous class also, like what is the slicing operator. So basically just see this, we are taking all the characters except the last four. Okay, so last four are basically this .npy are the last four indices, right? And everything before .npy is our name. So basically this names class id contains our name basically. Okay, and here we are just loading our data and appending this particular name and data item in my face data array. Okay, so face data array is this. So we are just appending every data in this face data array. Okay, and now just see that now we are making a particular target variable, like suppose we have 5 persons, person number 1 2 3 4 5, and these 5 persons are the family members. Okay, and now like we have to make a particular array, a particular scaled down array with that 5 person. Okay, so just see that like we have to make different target arrays for that. So initially my class id is 0. So like just see this line So basically, like we have target variables for different faces. Like we have stored our facial data and now we are just simplifying that data into target variables. Okay, so target are nothing, just a simple array. Okay, so basically what we are doing is like initially like we are having classes, like initial class is 0, and after that like will be incrementing our class ID with every iteration. So a particular class ID is associated with every face data. Okay, initially my class ID is 0, and now just see this, like I have got my data item, and I'm just taking the shape of the data item, like the length of my data items. Data items are basically the number of times our face has been stored. Okay, so like I'm just calculating the length of the data item and like converting that into an array of ones. So I'll be forming an array of ones with the length of the data item. Okay, the size will be length of the data item, and I am multiplying it by class ID. So my class ID is 0. So when 0 is multiplied with the np dot ones, it will become an array of zeros. Okay, so this will be my target number 1. After that, like I will increase my class ID, I will increment it, I'll store that target in the labels array, and I will just move to the next iteration. After that, I will go to my second phase. Okay, and what I will do is like I will get in another data item. I will calculate the size of the data item because I'm having a different person now, and I will convert. I will make a array of ones, and the size of that array will be data item size. Okay, and I will multiply that by class ID. So whenever an array of ones is multiplied with class ID, which is 1, so it will become the same array again. So that will be my target number 2. And similarly, when class ID are being incremented, so basically like when class ID is equal to 2, when 2 is multiplied by array of ones, then it will become an array of 2. Okay, the basic difference is that the size of these all the target arrays are different. Okay, based on the particular faces, the size of arrays are different and the number of the arrays are different. Okay, so that's how like we are just modifying the facial data into target variables and storing all the data in this labels. So labels is also an array. We are just storing all the different face data in labels. Now we are just printing that data, like what are the face data we have, what are the face labels we have, all that simple stuff, and just combining that into np, like np.concatenate face data and face labels. So face data is the face data and face labels are the labels of the faces associated with that. Okay, and now just see that like we have printed that stuff, and now like this is my font, this line doesn't care as of now, and now just see that like this line. Okay, so now just see that like so now like we have like stored our facial data, like we have extracted our data from the data set, and we have just stored that data. Okay, now like we have to implement our, like we have to call our kNN function, and we have to make a box around our face. So what will happen is that when you store your face data, okay, and like one part is storing our face data in face data.py file, and now like when we are recognizing it, like open your camera, like play this file, your camera will be open, and when you will show your face in front of the camera, a box will become around your face and your name will be written above that box. Okay, suppose if I show you this, uh, we just see this. Suppose like we are having a face like this, and like what will happen is like when I open my webcam, suppose this is my webcam. Okay, this whole screen is my webcam, and this is my face. Like I'm having neck also, and like some, okay, like rest of the body and a face. So basically what our algorithm will do is like when we open our camera, then a colored box will be come around our face, which will be like this, which will cover only our face part. Okay, like okay, so a squared box will be formed around our face and our name will become here at the top. Okay, so our algorithm will do that. So like this is our webcam and this is me or anything or you, and a particular green color box will be come around this, and this is due to this Haar Cascade classifier, which is like defining our face basically, and our name will be written over that. So let me just show you that code. So basically like we are just doing the same thing again, which we have seen earlier also. Like we will start a loop, an infinite loop, which will be recording our camera. So we will start our camera by cap.read, and this ret and frame will basically be having our camera variables, like webcam variables. Return is basically like telling us that whether the camera is on or off. Okay, and frame is basically our main camera frame which we'll be using. Okay, so first, like we have just converted our image to a grayscale image. Okay, like whatever the video we are having, we have just converted that into a grayscale video. And after that, like we are done same thing. Like we have just detect multiscale, and these are the scaling factor and the number of neighbors. Like we have seen all this part in earlier video also. Okay, just get over the here. So this faces will basically contain our coordinates of the faces like x, y, w and h. So basically if I change the plane, so this corner, like top left corner, will contain the will having the point number x and y. Sorry, I don't have the mouse, so I'm typing like this. So x and y are the coordinates, and this is our width, and this is our height basically. Okay, so basically our this function will give us the x, y, width and height. So that all will be stored in the face array. Okay, and now like we are just starting a loop. Okay, so like in the new loop we are having a face, and with a face we are having the coordinates, and these coordinates are got from this face. Okay, so this face is basically the one face on which we are iterating, and everything this is same, just we are just cutting the part of the camera frame and just converting that to 100 cross 100 frame size. And now just see this, out is equal to knin. We are calling our function, just concentrate here, we are calling our function knin, and now like train set and face section flatten. So face section dot flatten. So basically training set is our training set which we are carrying over from the past time, and face section dot flatten means like we are defined this earlier also. Like we are having a face section, just see here, we are having a face section, basically the camera frame which is just calibrating our face. So we are just flattening that to convert that into an array. Okay, of one column and multiple rows. We are just flattening that because in knin our parameter should be a flattened array, only a array of one column. Okay, so our train set, we have that, we have our new face, just we are just passing the two parameters, and this will give us the output will be that face. Like training set we have trained, and face section is the section we got here. So it will basically guess the output that which frame we are having currently. So train set we got from data, face data. Okay, all the face data we have. So it will just iterate over every data and just apply our knin algorithm on that. Okay, which is having a training set and a test set. Okay, on the basis of that it will give us the prediction, which is this, and it will tell us that which point it belongs to. Okay, so like if we have this basically like this is the stuff, like if we are having a face in between, so it will just tell us that which face does our face belong to from this rest of the 5 faces basically. Okay, and now like we have done that, like we got the output face from here, and now we have to make a box around the face and a text on the face basically. Okay, so cv2 dot rectangle is a function which is used to make a shape by OpenCV. So what we are doing is just we are passing a frame, the coordinates, the top left coordinates and the bottom right coordinates. Okay, top left are xy and bottom right are x plus w, y plus h. We are passing the coordinates. Okay, and it will make a face around it. It will make a rectangle in these coordinates, and this is the color, and this is the width. width of the box. Color is 255, 255, 255, which this is basically BGR colored. Okay, blue, green, red. Okay, like if I do 0 here and if I do 0 here, so BGR means B, G and R. So if my B and G are 0 and my R is 255, it will make a box of red color. Okay, and if I make this like if I make this 255 here, so it will make a green color box. Okay, this is just a color format. And now like to put a text like here, like we write a function cv2.put text and it will just put a text here, and this is the font of the text, and this is the coordinates where I have to put my text, and this is my color of the text like BGR format. B is 255, so my text will be of blue color. Okay, and this is the width. Okay, and similarly like that we are just putting everything, and now like we are just displaying our face. Okay, like we are just showing our camera feed and all of that. Okay, and after that everything just we make a function like if I press a key Q, so my function will be end there and I can close my webcam, and my webcam will not be closed by anything except pressing Q. Okay, and now like after all everything we will just destroy the window and close the program. That's all. Okay, like this is a project of face recognition, and I hope that this is a very beginner level project in machine learning. Okay, so like I hope that this will be clear to all of you, and just write the just give the comment below that how how much you like this playlist of this project. Okay, and okay, so let's end this video now. Okay, bye.